In previous videos, we've talked about how to generate random values and the various different ways we can go about that. We've briefly introduced some of the macros that are available to us to help us calculate different mathematical expressions. The last real missing piece of creating a question in MyOpenMath is to define the answer and look at some of the options that come along with that. The first thing we're going to do is take a look at question type number and numeric. This means that whatever our answer is, it's going to be a number. Acceptable answers for this case include integers or decimals. In order to do this, we first have to define in the common control what our answer is. This could either be a specific number, if we have a static question, or if the question always ends up having the same answer. The answer could be a variable that we've defined somewhere in the problem. So if we're generating two random values and somewhere we calculate the sum of those two numbers, whatever we define that sum to be would be our answer. So whatever value a student should put in for the answer is going to be here. We're just going to use a static number just for demonstration purposes. We could also input a list of multiple acceptable answers. So if the question was like input an odd number that's less than 8, then we could put 1 or 3 or 5 or 7. And then the system would accept any single value as a correct answer. We might also have problems where we want to accept a range of values. For instance, if we wanted to ask a student to enter any value between 2 and 5, then we could put a set of parentheses and with square or rounded brackets, put an interval from 2 to 5. Obviously, if we put a rounded bracket, that would mean values up to but not including 5 would be acceptable. We can also insert a list of numbers. So if the answer should be a list where students have to enter all of those values. So this is different than the statement with or included in there. Here, all of the values have to be present in order to have a complete solution. So depending on specifically what you're after, as long as the answer is a number or a list of numbers, then this process will work. In addition to defining the answer, which we'll go back to just a static value 3, we have some answer variables that we can include, which include relative tolerance or absolute tolerance. In this case, we can define the relative or absolute tolerance for the question, meaning how close does our answer have to be. So 0.01 would be 1%. For absolute tolerance, if we put in a 1, then we have to be within one integer of the correct answer for the problem. So if you want to allow some tolerance for rounding errors, things like that, make them be within a 100th of the correct answer, a 10th of the correct answer. You can include those. Obviously, we'd only want one of those because those two statements conflict with each other, or those two different types of commands can conflict with each other. We can also include the option to require decimals. It would help if I spelled that correctly. Require decimals. And we have a few different options here. We can set this to be a whole number value, which could be as small as 0, and there probably is some upper bound on it, but up to say 4, 5, 6, 7, 8, however many decimal places we'd want to have. This would allow for rounding to be less than that. So if we had a number that rounded to a whole number, this would still be correct, but we wouldn't want to go beyond 2 decimal places. We could also put inside a set of parentheses the statement equals to. In this case, the system would be looking for exactly 2 decimal places. So for this scenario, 2.4 would not be accepted as a correct answer, even if that is the correct answer mathematically. But 2.40 would be what we would need to plug in to have exactly 2 decimal places as accepted as part of that correct answer. So we just need to be careful with that statement. Students would have to put trailing zeros in those cases. Another way to deal with that, if you want to round to exactly 2 decimal places but not have trailing zeros, would be to put inside a set of quotation marks R2 or R3, R4, depending on how many places you would want to include. In this case, both 2.4 and 2.440 would be correct answers. So whether we use equals to or R2 just makes the difference of whether or not we have to include those trailing zeros in our answer. And I keep typing decimals wrong. Let's go back and fix that. Another option with required decimals would be to put equals to, so we need exactly 2 decimal places, but we could include a plus or minus 0.01 or plus or minus 1%. Either way, I think I might have had that minus missing the first time. So we should have plus or minus 1% or plus or minus 0.01 if we want to have exactly 2 decimal places. And this is another place where we can add some tolerance. So in addition, and instead of using the relative or absolute tolerance statements above, we can put that little bit of wiggle room for rounding errors in here. We obviously wouldn't want to have 3 different required decimal statements. I'm just demonstrating some of those different options we can use. So you would include whichever rounding option, if any, is necessary for your problem. There's also an answer format option. This allows us to put in an array of different commands for the format of our answer. For instance, if we had that list of values, if our answer was supposed to be something like 1, 2, 3, then we would need this answer format list so that it knows it's looking for a list of values separated by commas. There's also options to include exact list if duplicates matter. So when we use that list command, it doesn't check for duplicates, but if we use exact list, then if 3 is supposed to appear twice in that answer, then we would need to have both 3's represented in our answer to get credit for that. There's also the answer format for set, which is same as list, but it expects curly braces on either end of your answer set. And the last one we want to take a look at is either no solution or no solution infinite. What this is going to do is add some radio buttons for us to select that either no solutions exist, and if we add that inf statement at the end, infinite solutions exist. In order for students to see a place to enter their answer, we have to enter an answer box somewhere in our question text. So we could say something like, this is the answer, and then we would put a $sign answer box. So in the common control, we defined answer. In the question text, we include answer box, and that's where students would put that answer. Let's go back and change this to 3 since I don't have that list command. And we'll click Quick Save and Preview to see what this would look like. So this is the answer. Since we have this answer format, no solution infinite option, there's either a single solution, in which case we would want to put 3 since we define that as the static correct answer. And for me, this is getting marked wrong because I have these required decimal statements that are throwing this off. So let's go back and get rid of those required decimal statements. Now, if we enter 3, we would have the correct answer. We can check that that's the correct answer. But if we had a case where there was no solution or an infinite number of solutions, students would have the option to check those boxes, and we would have to program with some if statements when there's a solution and when there's not. So we could have another answer say D and E or infinite solutions to reflect that. And we would need to define those cases using those if statements. So we would need some other test variable. So it's 3 whenever our test variable is equal to some value. And then in another case, say if it's not equal to some value. So we'd have to use some of those other tools that we've looked at, other commands that we've looked at in previous videos to define if and when we would have does not exist solutions as a possibility. Which actually reminds me of 2 other possibilities for answers that we need to discuss here. We could have the possibility that our answer is does not exist, And let's get rid of these radio button options. In the case where our answer does not exist, we can see that D&E text pop up as the correct solution. To enter that, students would literally equal D&E to get that correct result. This numeric numeric answer format also allows positive or negative infinity as a solution. We could actually go ahead and accept either answer, either negative infinity or infinity, which we indicate with two lowercase zeros next to each other. And then a student could enter that same double lowercase o format to get that infinity symbol, or for the system to treat that as the infinity symbol.